Welcome to Exponent Basics Part 2 with the Alberta Curriculum Tutor. For the first part of today's lesson, we will be covering why any number to the power of 0 equals 1. So, in order to explain this, I'm going to be demonstrating this using a base of 2. So, let's write out a few exponents. We have 2 to the power of 4, 2 to the power of 3, 2 to the power of 2, 2 to the power of 1, 2 to the power of 0. And what do these numbers equal? Well, we know that 2 to the power of 4 equals 16, 2 to the power of 3 equals 8, 2 to the power of 2 equals 4, and 2 to the power of 1 equals 2. And I have told you that 2 to the power of 0 equals 1 because any number to the power of 0 will always equal 1. Now, if we look at this row of numbers, we can see a pattern. Every time the exponent gets smaller by 1, the number halves. Every time you're dividing by 2. And therefore, in order to keep this pattern up, 2 to the power of 0 must equal 1, because 2 divided by 2 equals 1. Now, I will now show this using the power of a base of 3. So, 3 to the power of 4, 3 to the power of 3, 3 to the power of 2, 3 to the power of 1, 3 to the power of 0. Okay. 3 to the power of 4 equals 81. 3 to the power of 3 equals 27. 3 to the power of 2 equals 9. 3 to the power of 1 equals 3. And any number to the power of 0 equals 1. So, in this case, the pattern is as the exponent decreases by 1, the number will actually be divided by 3. So 27 is equal to 81 divided by 3. 9 is equal to 27 divided by 3. This continues. And therefore, in order to keep this pattern up, 3 divided by 3 equals 1. So in this case, you'll notice that we're not having, as we did in the last case with a base of 2, we're dividing by 3. And what you'll notice is this number that we're dividing by is the same as the base. So exponents have this pattern. And in order for this pattern to keep working, any number to the power of 0 will always equal 1. So if you ever want to find a number, you can always try and use this pattern to work out the exponents, and then you'll see that 3 to the power of 0, or any number to the power of 0, will equal 1. So you are welcome to try and prove this with a base of 4 or a base of 5, anything you like. Now we're going to talk about how we use exponents with the order of operations. So I'm sure you know that when following order of operations, you should always multiply and divide before adding and subtracting. But what if you're given an exponent? What should you do? Well, let's take a look at what the order of operations are. I like to use BEDMAS. Some people also use PEDMAS. Instead of brackets, they call them parentheses. So, BEDMAS stands for brackets are first, then exponents, then division, multiplication, addition, and subtraction. It's also important to remember that these are that the division and multiplication are interchangeable and addition and subtraction are interchangeable. The only reason that they're in this order is that because it fits nicely with the acronym. So, as we can see, exponents are the second thing that we do when going through our order of operations. So this means before doing your division, your multiplication, your addition, or your subtraction, you should always do your exponents. That means that if you're given 2 to the power of 3, make sure that you convert that to 8, because 2 to the power of 3 equals 8 before you do anything else, like division, multiplication, addition, or subtraction. Okay, so now we're going to use order of operations to solve a problem, and it includes exponents as well. So we're going to look at our BenMath, and we say, okay, brackets is the first thing. Well, I have brackets, so I'm going to solve whatever's inside the brackets first. So 4 plus 2 equals 6, and whatever inside the brackets was squared. So squared, you don't actually need the brackets though. That's going to be divided by 3 minus 2 times 5. Now here, just be careful that you don't do 3 minus 2 together, because it's important to remember that subtraction and addition are last, and it's quite a common mistake to do them before doing the multiplication or division or the exponents. So don't do that. Next is the exponents. So 6 squared is 36 divided by 3 minus 2 times 5. So next is division and multiplication. So we can actually just do these at the same time. So 36 divided by 3. 36 divided by 3 is 12, and then minus, and then we're going to do this set, because once we do the division, then we move to the multiplication over here. 2 times 5 is 10. And now we're just left with the subtraction. So 12 minus 10 equals 2. So that is how you get from there to 2 using order of operations. Okay, now we're going to talk about how one would go about doing 10 to the power of a certain number. And there's a little trick that I'll show you. So I'm just going to start off with an example. Let's do 10 to the power of 4. So if we write this in expanded form, that's 10 times 10 times 10 times 10. And what does that equal? Well, that's going to equal 10,000. And let's do another example. 10 to the power of 2 is going to equal 10 times 10, which is going to equal 100. Now, for the little trick, if you want to call it that. Whenever you have 10 to the power of something, you'll notice that there's a direct correlation between the number of zeros and the exponents. So in this case, we have 2 zeros, and our exponent is 2. Here we have 4 zeros, and our exponent is 4. So the correlation is whenever you have 10 to the power of a number, whatever number that is, that's the number of zeros you're going to have following the digit of 1. So if we took a really large number, 10 to the power of 10, let's say, well, I don't really want to write out 10 times, but we know that there's going to be 10 zeros following the 1. So 1, and we're going to have 10 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So, therefore, 10 to the power of 10 will be 10 billion. Okay, so we're now going to do a technique called scientific notation. This is often used in physics or other mathematics to express really big numbers in a nicer way, or multiplication, because sometimes you just don't really want to write out those big numbers and they're not favorable for what you're doing. So let's take the number 5,100,000. That's sort of a big number. I don't really like it like that. So I'm going to write this as a multiplication first. So one way you can write this is 5.1 times 1 million. So 5,100,000 is the same as 5.1 times 1 million. And if you want to prove that, you can just pause the video and figure it out for a moment. So, but this is still a big number. Doesn't really look any nicer than this number. But now we're going to use our exponents, and we're going to express this number as 10 to the power of something. So 5.1 times 10 to the power of something. And if you remember, I just taught you that little rule about how to do exponents when the base is 10. So we have 1, 2, 3, 4, 5, 6 zeros. So therefore the exponent is going to be 6. So this is scientific notation. It is okay. So we are now going to do another example of scientific notation. So let's try 412,000. So 412,000 is equal to 4.12 times 100,000. But this is not quite in scientific notation yet, because this number, 100,000, needs to be written as an exponent with a base of 10. So let's rewrite it again. 4.12 times 10 to the power of, well, let's just simply count the zeros. 1, 2, 3, 4, 5. So 5 zeros. So this is scientific notation for 412,000. Be careful when you're doing this that you don't write it as 412 times 1,000 and then go 412 times 10 to the power of 3. This is quite a common mistake, but this is incorrect scientific notation because your number over here has a greater place value than 1. So this would be incorrect. You need to make sure that your place value doesn't go bigger than the 1's digit. Congratulations on finishing Lesson 5 with the Alberta Curriculum Tutor, where we talked about Exponents Basics Part 2. So the main topics that we covered in this lesson were: why does any number to the power of 0 always equal 1? How to use order of operations with exponents. How to do exponents when your base is 10, and how to write numbers in scientific notation.
If you have a question or a math problem, such as a word problem, relating to today's lesson, please leave it in the comments and I will try and respond to you with an answer.